Pressure. Imagine gas molecules colliding in a container. The pressure is the force exerted per unit area by the gas molecules as they strike the surface around them. Therefore, pressure is equal to the force divided by area. Gas pressure. The pressure of a gas depends on several factors: the number of gas particles in a given volume, the volume of the container, and the average speed of the gas particles. This gas pressure is as a result of the constant movement of gas molecules and their collisions with the surface around them. There are four basic properties of a gas, and the physical state of a sample of gas can be described by each of these four basic properties. One is pressure, volume, temperature, and the fourth is the amount of moles. Knowing three of these four can result in the calculation of the fourth. These properties are all interrelated. When one changes, it affects the other. The gas laws describe the relationship between pairs of each of these four properties. The simple gas laws are the Boyle's law, Charles' law, and Avogadro's law. Early in the 17th century, Robert Boyle conducted a series of experiments on the relationship between gas volume and pressure. And what he found was there was an inverse relationship between volume and pressure. What this means is an increase in one will result in a decrease in the other. This resulted in the Boyle's law. Boyle's law states that the pressure of a gas is inversely proportional to its volume. Therefore, at constant temperature and a constant amount of gas, a graph of pressure versus 1 over volume would be a straight line. Therefore, as P increases, V decreases by the same factor. And so we say P multiplied by V equals to a constant. This becomes useful when we are interpreting pressure changes in a closed system. We use the equation P1 multiplied by V1 equals P2 multiplied by V2. What this means, if you are in a closed system at a certain pressure and a certain volume, and you change either of these, then the new pressure multiplied by the new volume should be the same as the old pressure multiplied by the old volume. Imagine a closed system with a volume of gas equals to 1 liter and a pressure equals to 1 atmosphere. If we decrease that volume from 1 to 0.5 liters, then the pressure will then increase to 2 atmospheres. Therefore, in the same system, although we have half the volume, pressure times volume is the same number. The first to study the relationship between gas and volume were French scientists Jacques Charles and Joseph Guy Lussac. And what their studies show was that the volume of a fixed amount of gas at constant pressure increases linearly with increasing temperature in Kelvin. What this means is that the volume of a gas increases with increasing temperature. This relationship allows us to compare the volume temperature conditions for a given sample of gas at a constant pressure. So V1 divided by T1 is equal to V2 divided by T2. Here we are showing Charles' law as it relates to volume and temperature, and you have a linear relationship between volume and temperature, and we extrapolate down to absolute zero, which is negative 273 degrees Celsius or 0 degrees Kelvin. Remember, Charles' law is applicable in Kelvin. The other gas law is Avogadro's law, and this came about from Amadeo Avogadro's proposal that equal volumes of different gases contains the same number of particles at the same temperature and pressure. This is what gave rise to Avogadro's law, which states that the volume of a sample of gas is directly proportional to the number of moles of that gas. And this, of course, takes place at constant temperature and pressure. So V equals to a constant multiplied by N, where N is the number of moles. Therefore, more gas molecules equal to a larger volume. And we count the number of gas molecules by moles. A combination of all three of these laws resulted in the ideal gas law. Therefore, Charles' law, Boyle's law, and Avogadro's law describes the relationship between all four variables: pressure, volume, temperature, and number of moles. An ideal gas is a hypothetical sample of gas whose pressure, volume, and temperature behavior is predicted accurately by the ideal gas equation. This ideal gas equation, PV equals nRT, describes the behavior of an ideal gas, although the behavior of real gases generally differs slightly from that which is predicted from the equation. In PV equals nRT, R is called the gas constant, whose value is dependent on the units in which pressure and volume are expressed.